Okay, I'm going to get started. Today we're going to do section 7.5. So we're going to be analyzing, or starting to analyze anyway, the graphs of quadratic functions, right? And all quadratic functions graph as parabolas. So either right side up if it's positive, or upside down if it's negative, right? Both parabolas, both x squared graphs. So the first part that we're going to talk about today are these three things, okay? Every parabola has what's called a vertex, okay? The vertex is the point of the parabola where it changes direction. So like on this one, it's the point where it stopped going down and then started going back up. So on this one, since it's upside down, this would be its vertex. Okay, now the vertex is a point, so it's going to always have an x-coordinate and a y-coordinate because it's that physical point on the parabola. Now, so that's what the vertex is. The axis of symmetry, axis or line of symmetry of the parabola is this line that just cuts that parabola right in half, either one. It makes it symmetrical on either side, okay? Now, it's a vertical line, right? It's the kind that goes straight up and down. So when you are talking about the axis of symmetry and you are asked to write the equation of that line, the equation of all vertical lines are always x equals a number, and it's always just going to be x equals whatever the x-coordinate of your vertex is. So for instance, I'll just make up a vertex. I'll just say the vertex is at 2, 3. If this is the vertex, then the line of symmetry that cuts that parabola right in half is just going to be x equals 2. The last thing that we're going to talk about on the first problems are called the minimum or the maximum value, okay? Every parabola has either a minimum, like this one, because its vertex is at the very bottom of the parabola, or it's got a maximum, which means its vertex is at the very top of the parabola. So you've got one or the other, just depending on if you're right side up or upside down. Okay, now your minimum or maximum value is whatever the y-coordinate is of the vertex. It's not a line, so we're not writing the equation of a line like we are here, talking about the line of symmetry. It is just simply a number value. So if I was talking about this parabola and its vertex was at 2, 3, it would have a maximum, if it's this one, maximum value of 3. Okay, so let's look at some of these, like number 1. All right, on number 1, it actually gives you the picture of the parabola. So it gives you a picture of a parabola that looks like this. And then do you see how on it, it also tells you this point right here. That 3, -3 is naming the vertex. It's calling this point, saying it's at 3, -3. Okay. The first question asks you, what is the vertex? Well, this problem actually tells you that the vertex is 3, negative 3. Now, make sure when you type in your answer here that it is an ordered pair, right? It is naming a point, so it is an ordered pair. So if you don't put it in ordered pair form, it's not going to mark it right. The next thing it's going to do is ask you the axis of symmetry. So remember, the line of symmetry is the vertical line that cuts that parabola right in half. And it always comes in the form x equals. You'll notice that even on the problem it says to type an equation. It doesn't just want to know the number. It wants to know the equation of this vertical line. And all vertical lines come in the form of x equals, which is going to be x equals whatever that x coordinate is. So that would be x equals 3. And then the last part says, what is the minimum or maximum value? Okay, so it doesn't ask you to name which one it is. It doesn't say to name it as a minimum or a maximum. It just wants to know the value. This one would actually be a minimum though, right? Because it's at the bottom. So since it's this right here, that negative 3 is the minimum value. This is not an equation. It is just a number value. Okay, so that's how you would do number 1. All right, number 2 asks me all the same kind of questions, but it doesn't give me the picture. It just gives me the written out function. So we have got to kind of draw the picture on our own and find its vertex. I'm going to show you 2 ways to find the vertex. So it tells me the function is f of x equals x squared minus 6x plus 8. All right, for those of you who like to do your work by hand, I'm going to show you the written out way to find the vertex. And then for those of you who like to do the calculator, I'm going to show you how to do it in the calculator. Okay, now the opposite of b over 2a. So this should look familiar from our quadratic equation. Because it comes, everything about quadratic equation is quadratic. You can get all kinds of information from it. This part right here, that opposite of b over 2a, is where this part of the problem comes from. I can use the opposite of b over 2a to find the x coordinate of the vertex. Your same numbers are always a, b, and c. A is the number in front of x squared, b is the number in front of x, and c is your constant. So the first thing I would need is the opposite of b. Well, if my b is negative 6, then the opposite of it's going to be positive 6. Over 2 times a, so 2 times the number in front of x squared is a 1. So that leaves me with 6 over 2, which is 3. So this is, I'm working on the vertex, that's the x coordinate of the vertex. So if we know what x is, can't we just replace the x's in the function with 3's now, which will solve for y, right? Because f of x isn't f of x and y mean the same thing. So if I replace my x's with 3's, I will have 3 squared minus 6 times 3 plus 8. 3 squared gives me 9. Minus 6 times 3 is 18. Plus 8. So if I add and subtract straight across, 9 minus 18 is negative 9. Plus 8 gives me negative 1. So there is the y-coordinate of your vertex. So now you know the whole thing. You know the x-coordinate and the y-coordinate, which means I can also answer the rest of the questions. The axis of symmetry would be what? And remember, axis of symmetry is always an equation of a line. So it's going to be x equals 3. And this one, I'm going to graph it in just a second to show you how to find the vertex on the calculator. But this one does ask me if it's going to have a minimum or a maximum value. So what tells us this? The x squared, right? Since it's positive, this parabola will be regular. It won't be upside down. It doesn't have a negative in front of the x squared to flip it upside down. So this one is going to have, its vertex is going to be at the bottom, which means it's going to have a minimum value. And remember, the minimum value is just whatever the y-coordinate is, which in this case is negative 1. Okay, so let's figure out how to find, if you didn't want to do all of this part right here, let's find out how to do that in the calculator. So go to your y equals. And clear it out. Sorry, I couldn't get my calculator to work. So I'm going to put in x squared minus 6x plus 8. So your x button, then your squared button. Minus 6x plus 8, minus 6x plus 8. So let's graph it to see what it looks like. So just like we thought, it's going to be a right side up parabola. So I want to find the vertex. So let's see this right here. The vertex, first of all, we're going to have to tell the calculator in just a minute whether or not we're finding the minimum or the maximum of the vertex. So this one is at the bottom, so we're going to tell it to find the minimum of this parabola. So hit your second button. And then hit this trace button. You'll see right on top of trace, it says calc. See it? So I want to tell it that I'm going to find the minimum. So go down to number 3 and hit enter. Now it's going to ask me 2 questions. The first thing it's going to ask me is my cursor on the left side of the parabola? So you move your cursor with your left right arrows. So if you do you see the cursor? So is it on the left side of the parabola? It is, right where it is. It doesn't matter where on the left, anywhere on the left. So just hit enter. The second thing it's going to ask you is your cursor on the right? Well, it's not because it's on the left, right? So keep pushing your right arrow until you get past the vertex and then over to the right side. It doesn't matter where, anywhere on the right side. Hit enter, and then it's going to say guess. That doesn't mean anything, so just don't worry about that. Hit enter again. There's your vertex. 3, negative 1. Okay? This 3.000004 just means the same thing as 3. So it's at 3, negative 1, just like we found. Okay? So I'm going to use this method for the rest of the problems because we don't have time to do both methods. And that way, it can also get you practice. Okay? And then you're going to have to graph it in MathLab. Okay? Number 3. Same same kind of problem. It gives you the function written out like this and then asks you the same 3 questions. All right, our function this time is f of x equals 2x squared plus 10x plus 14. So I'm going to use my calculator. So I'm going to go to y equals, because the first thing it's going to ask me is the vertex. So I'm going to go to y equals and clear out the last problem and put in this one. So I'll have 2x squared plus 10x plus 14. I'm going to graph it. It's a right side up parabola again. So if I'm going to find the vertex, that means go to second and then trace to get up to that calc function. So remember, it was right side up, which means its vertex was at the bottom. So I'm going to find the minimum again. So if you can't see your cursor, which I can't on this one, this x and y down here at the bottom is telling you where it is. So it's at 0, 14. So my x is 0, my y is 14, which means it's up here around the 84 of the TI of the name. Okay, which means it's on the right side of the parabola, right? So I just need to keep hitting my left button and eventually you'll see it. So there it is. Move it over to the left side of the vertex, anywhere. Hit enter. Hit your right button to get it back over to the right, anywhere. Hit enter twice. So your vertex for this one, oh, I'm glad this came up, is at negative 2.5, 1.5. So when you're entering your answer in MATLAB, it says to enter as an integer or a fraction, okay? So this is not just wasted numbers though, because you are gonna have to graph this in MATLAB, which means I am gonna be seeing those decimals is actually beneficial, right? You don't wanna see a fraction here and here if you're trying to move to the left and up. You wanna see it in decimals, and the decimals is what the MATLAB graph is gonna show anyway. But when you enter your answer, it's going to want it entered as a fraction. Okay, so if you forgot how to turn decimals into fractions, just do that work in your calculator with your math enter button. So just enter the negative 2.5, hit enter, then hit your math, and then hit enter twice, right? That's what turns your decimals to fractions. So I'd have negative 5 halves. And then do it again for the 1.5 to get 3 halves. So that's what you'd enter for your vertex. I can get all the rest of my answer from that part right there. The axis of symmetry is x equals the x coordinate, so negative 5 halves. Again, this one was right side up, right? Doesn't matter where it is. I'm just deciding if it has a minimum or maximum. So this one has a minimum value. Of this y coordinate, which is 3 halves. Okay, number 4, f of x equals negative x squared minus 4x minus 10. So I'm going to put this one in my calculator. This one's going to be upside down, right? What's making it turn upside down? This negative. So this one's going to be an upside down parabola. So let's put that in our y equals. So negative x squared minus 4x minus 10. And our y equals, and then graph it. There's our upside down parabola. So if I'm going to find the vertex, go to second calc. This one, I'm going down to number 4 though, right? Because this one, since it's upside down like this, when I'm finding the vertex, I'm actually finding the maximum value of this one since it's flipped upside down. So you'll go down to 4 until you want to find the maximum. Then it's going to ask you the same question. So left bound, it's not on the left, it's at 0, negative 10, which means your cursor is right here, which means I need to move it across the vertex over to the left side. So just be hitting your left. So there it is. Move it across the vertex over to the left and hit enter. And move it back across and hit enter again, twice. So this one's vertex is, what does this mean? It's mine, it says negative 1.9999998, which just really means negative 2, negative 6. So the vertex is at negative 2, negative 6. The axis of symmetry is x equals negative 2. This one has a maximum value, right? Since it's upside down and its vertex is at the top, its maximum value is negative 6. Okay? Numbers 5, 6, and 7 are some true-false questions. So it's going to give us a statement about a parabola and then ask you if it's true or false. So let's look at number 5. F of x equals 5x squared minus 7x plus 2. So this statement says this function has a minimum value, which just means, is this parabola have a minimum or a maximum? If it doesn't have, if your x squared is positive, that means it's a parabola that looks like that, which means this one does have a bottom, which means it does have a minimum value. So that one is true. That parabola, if you graphed it, would have a minimum, not a maximum. All right, number 6. Determine whether this statement is true or false. It says h of x equals, in parentheses, x plus 6 squared, and it says this graph can be obtained from translating the graph of h of x equals x squared to the left 6 units. So this is going back to that transformation section, right? With our inside and our outside numbers. So what would a plus 6 inside do? Remember what inside numbers do? They shift you left and right. but you go opposite of the sign. So this plus 6 would actually shift you to the left 6. So that one's also true. It would shift the x squared graph to the left 6. All right, number 7 also goes back to our transformation section. It says the axis of symmetry of f of x equals 9 times x minus 6 squared plus 7 is x equals 7. So let's think about, remember what these two numbers here are going to do to your x squared graph. So a regular x squared graph is right here. It starts right, the vertex is right there at the origin. So let's think about what these two numbers are going to do with this parabola. The point that is shifting is the vertex. So let's see. Excuse me, thank you. So this plus 6 in the parentheses would actually move it where? To the right 6. This would move it up 7. So let's see where that's going to put our parabola. If I'm moving this vertex to the right, 1, 2, 3, 4, 5, 6, and then up 7, my vertex will be here. So my parabola has moved up there. So let's see, what would its axis of symmetry be? Where did I just move this point? Well, I moved it to the right 6. So my x-coordinate is now 6, and I moved it up 7, which means my y-coordinate is 7. But this statement says the axis of symmetry is x equals 7, which is not right, right? Since this right here, the x should equal 6. The axis of symmetry is that x equals 6. So that's why that one would be false. All right, I'm going to put on one of these masks. Okay, now getting into numbers 8 and 9. All right, it's going to give us the same kind of information, and then it's also going to ask us about the vertex and the minimum or maximum value, and then it's going to ask us some new questions. So let's look at number 8. Again, all this information is going to come from the vertex. So let's look at number 8. F of x equals x squared plus 10x plus 16. So the first thing it's going to ask me is, where's the vertex? So let's go to our y equals and find the vertex. So I have x, so into y equals going to x squared plus 10x plus 16. So let's graph it. So there's where your parabola is going to be. So let's find its vertex. So second calc, since it was right side up, remember the vertex is at the bottom, so it's going to be at the minimum. Hit enter. So let's see, where is our cursor? It's at 0, 16. So it's way up here. So we need to move it down, cross through the vertex, and put it over here on the left side. So just keep hitting your left button. There it is. Still on the right side though. So I need to move it across and put it anywhere on the left. So there it is on the left. Hit enter. Now move it back to the right. So there it is on the right. Hit enter twice. So my vertex is at -5, -9. Then it's going to ask you whether or not it has a minimum or a maximum value. So let's draw this one out. We're going to want to see it in just a second anyway for the rest of the problem. So here's my vertex at -5, -9. It's right side up, right? Since it didn't have a negative x squared. So I'm going to draw this vertex and draw that parabola. Okay? So this one has, it's got a minimum, right? Because the vertex is at the bottom. So the minimum value would be that -9. Okay, new information. Now it's going to ask you, well, what is the range of this parabola? The range is the y values, right? So this right here tells you your minimum y, your minimum value. So the minimum of the range is going to be that -9. What do the y values do on both sides of that vertex? They both, from this -9, they go up and they go up for how long? Forever. So here's what I want to say. I want to say my range because I have to put it in interval notation, which is what has the parentheses and brackets and infinities and all that. I want to say my range is from -9 and then up forever. So from -9 to infinity. Now, infinities always have parentheses. So that one's not hard to figure out. It's always got a parenthesis. So I want to decide whether or not my -9 needs a bracket around it or a parenthesis. Which means, do I want to include -9 in this statement or not? Is -9 part of the range? Well, yeah, it is. It's this point. It's the smallest number in the range, but it is part of it, which means that -9 has a bracket around it. All right, the last two parts of the problem are going to ask you, where is this function increasing and where is it decreasing? When you're increasing and decreasing, you're always going to use the x coordinate of the point that you're talking about. Okay, so increase and decrease, always use x coordinate when you are naming the intervals. Again, this is an interval question, which means I'm going to enter my increase and decrease as an interval answer. So let's see. Decreasing is where it's going down. Increasing is when it's going up. So this side is decreasing. And this side is increasing. So it wants to know, where is it increasing? The vertex is the point where it stops decreasing and starts increasing. So we're going to use the x coordinate of the vertex when we're talking about it. So where does it start increasing? It starts increasing at -5, and then it increases to where? How long does it go up? Forever, right? So this right here, I want to say from 5 to infinity is where it is increasing. Infinities always have parentheses. Now, -5, sorry, thank you, -5. I want to decide whether or not I'm including this -5 in the increasing part of this, and I don't want to include it, right? -5, it's not doing this or this at this point, right? You can't be, it's not doing either one. It's where it stopped decreasing and then it started increasing. So it's not doing either one of these things at that one point. So that's why that -5, you don't want to include it. It's not increasing at -5. That's where it's kind of in between the increase and decrease. So where is it decreasing? So let's see, it's going down. It stops decreasing at -5, right? So -5 is my end of the interval that it's decreasing, which means it started decreasing all the way to the other end of the number line, which is the -infinity. So it's going down from -infinity until it gets to -5. All right. Two more. Number 9 is another problem like this. It's a little bit different because it's going to be an upside down parabola. But again, finding the vertex, you can see all of these numbers in all of the rest of the problem come from that vertex. All right, number 9. F of x equals -8x squared minus 24x plus 9. I got you, Devin. Okay, so first things first, we got to always find the vertex. So let's go to our y equals and clear it out. Type in -8x squared. So there's your -8. There's your x. And then your x squared. So that'll just square your x for you. Then minus 24x plus 9. So let's look at this one. So let's graph it. It's going to be upside down. So did you see while it was drawing it, it started way down here. It went up to where I couldn't even see the top of it and then came back down. So it's an upside down parabola. Let's find out where its vertex is. So second, then hit your trace button to get up to the calc function. So this one is an upside down parabola, which means its vertex is the top or the maximum, right? So go down to number 4 to find its maximum. So let's see, where is our cursor? Is it on the left? So it's at, right now it's at 0, 9. So it's right here. It's right up there in this function sentence. So it's right here, which means it's on the right side, which means I need to hit my left button until it gets, I can see it over here on the left. Now, when I'm hitting my left button, look at your Y values. You just need to see they're still going up, 13, 17, 21. What's going to happen to those Y values once I get all the way up to the very top and pass through the vertex? Those Y values are going to start coming down. So you don't even have to wait until you see the cursor. Now I'm at 23, 25, 26. Now I'm back to 25, which means I have gone all the way up to the top. I've passed through the vertex, and now I'm on the other side of it and coming down. Okay, if you feel more comfortable to see it, just keep hitting your left. It'll eventually get down there. There it is. And hit enter. Now, same thing's going to happen. I'm going to keep hitting it to the right. Do you see I'm going back up the parabola, so my Y's are going up again. Oh, I must have passed through the vertex because now they're coming back down. And I can do it until I see it if I want. Okay, there it is on the right. So hit enter twice. So my vertex is at negative 1.5, 27. Now, remember, MathLab's not going to want you to type in negative 1.5. They're going to want you to type in the fraction, which would be negative 3/2. 27, right? So if you just want to, you can type in negative 1.5, then turn your decimal into a fraction by hitting math, enter, enter. All right, so there's my vertex. Let's go ahead and just sketch this out so we can just see what we're talking about. So it's to the left 1.5 and then up 27. So I'm just going to do a rough sketch. So I'm just going to say left 1.5, up 27. So my vertex is somewhere up there and my parabola was upside down. So there's the vertex up there at the top of that parabola. So the next thing says the parabola, does it open upward or downward or have a minimum or a maximum? So since this one opens down, that vertex is at the very top, which means it has a maximum value of 27. All right, this range is going to be written a little bit different since the parabola is upside down. This time, 27 is the highest Y value. Remember the last one, we had a minimum, so that number was the minimum. So what is my range? If this is my very highest Y right there, 27, which means all the other Y's are below it. Which means, what about our range? 27 is going to be the end of it, right? Now, what do the Y's start at? If they come up to 27 and then go back down, 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 where are they coming from and going to both times? Negative infinity. Infinities always have parentheses. And what do I know about the range? Is 27 a number that is in this function? And it is. It's its vertex number. So that's why there's a bracket around that. And then the last two parts of this question are the increasing and decreasing parts. So let's see. This is the side that's going up. So that's going to be your increased side. Once it hits the vertex, it starts going down over here. So there's your decreased side. Now remember, when we're talking about increasing and decreasing, we always use the x coordinate. So it starts at negative infinity and goes up until it gets to what? Negative 3/2. So from negative infinity to negative 3/2, the parabola is increasing. Once it hits that negative 3/2, what does it start doing? It decreases. So where does it start decreasing? It starts decreasing at negative 3/2. And it increases forever to the right. So keeps going up. Coming down. All right, last problem, number 10. Is a word problem about a toy rocket. So it gives us all these words about a toy rocket being blasted off. So think about shooting a toy rocket off the ground. What's going to happen to it when you shoot it off the ground? Okay, say you're at the ground and you shoot a toy rocket, it's going to go up and up and up and up, and then at some point, it's going to start going down. So it's going to reach this maximum height at some point, and once it gets there, it's going to turn and fall to the ground. So it gives us all these words, and then it says the function that we are going to use to describe this curve, what's happening with the toy rocket is h of t equals negative 16t squared plus 40t plus 3 is the function of that parabola shape. So it wants to know two things. It wants to know the rocket reaches its maximum height at how many seconds? And what is the maximum height? So it really wants to know what this vertex is. The x-coordinate is going to tell us how many seconds it takes to get there. The y-coordinate is going to be the maximum height that the rocket goes. So I just need to find the vertex, which means I'll just go to my y equals, clear it out, and type in this function. I don't have t's, but it doesn't matter. I'll just put in x's. So negative 16x squared plus 40x plus 3. So let's graph it. Now, it's going to be an upside down parabola. But did you see it went way up here, and I just don't see the top of it, and then it goes back down. So I need to find the vertex of this parabola. So second calc, and it wants me to be on the left. Oh, wait, what do I got to tell it first? Am I finding a minimum or a maximum? Since it's upside down, it's got a maximum, right? It's got a top to it. So go down to 4. Now it wants to know if you're on the left. Here's where your cursor is. Your cursor is at 0, 3. There it is blinking. So I need to, oh, it is on the left. I can't tell when I'm looking at it backwards. So this right here, it is on the left. So go ahead and tell it that. Say, yeah, it's on the left. Hit enter. So now you want to put it to the right. So you're just going to keep hitting that right. It's going to go way up here to where you can't see it. And then come back down to the left side. But remember, you can watch your y's. So it's at 3 now. As long as I'm moving, as long as the y's are going up, that means I'm still on the right. I haven't got to the vertex yet and started going down. So just keep moving. See how your y's are still going up, 27. And then they came back down. And hit enter. So here I've got 1.25, right? That's what 1.2499997. That's 1.25, and that is 28. So the vertex is at 1.25. 28, which means what? It took 1.25 seconds to go to its maximum height, which its maximum height was 25 feet. Okay, so I got Davis, Ledoux, Altangero, Macaulay, and Devin on Zoom. All right, I will see y'all on Monday. Have a good weekend.